Howdy and welcome to your Benzene Academy Safety Meeting. This month we're going to be going through Hazcom, GHS, NORM, TeNorm, and Benzene Awareness. This all stems from 1910-1200, which is the Hazcom standard from OSHA. Sit back, relax, and let's get this meeting underway. Let's start off by going through the Hazcom session objectives. Objective 1, learn what Hazcom is. Objective 2, learn how to protect yourself from hazardous chemicals. Objective 3, know how to use the ERG guide. Objective 4, know how to use the SDS or the safety data sheet. And Objective 5, understand that you have the right to know what hazardous chemicals are in the workplace and how to protect them. That is OSHA's right to know and right to understand law. So, what is Hazcom? Hazcom is the communication of chemicals or toxic substances to the employees that work with them. Hazardous substances can have a negative effect on people or the environment. They can make you sick, cause cancer, or physically harm you. Hazcom is known as the right to know law and right to understand law. It gives you the right to know about the hazardous material in your workplace and how to protect yourself. It became part of the GHS or the Globally Harmonized System in 2014. Becoming part of that system brought the world together in hazard communication. Within your hazard communication program, you have to have the actual written program, a chemical inventory, label requirements laid out for the customer or employee, SDSs or safety data sheets, and you have to train your employees on the requirements and all the statutes of the hazard communication standard. So we're quickly going to talk about written programs. Companies are required to have a written program that is available for you to review, the employee. You should be trained in the program and its required elements. You should have training and knowledge on the chemicals in your workplace, especially ones you work with or that you are required to work around. And companies are required to protect employees from these hazards. When we talk about chemical inventories, they are a little separate from SDSs. Companies will keep an up-to-date chemical inventory. Employees need to have access to the chemical inventory at all times. They can't lock it away. They can't prevent you from using it or reading it. It must be somewhere where an employee can readily get to it, usually where the chemicals are stored. New chemicals need to be added to the inventory before arriving on location. Employees need to be trained on the new chemicals before being allowed to use them. This includes chemicals being brought into the facility by contractors or one-time use only chemicals. So it really doesn't matter what hazardous chemicals you have in the workplace, they all must be in this. Now this brings us to labels. Chemicals must be labeled appropriately to protect workers. Chemicals being shipped will have GHS labels, and all containers and secondary containers must have labels affixed. Now the GHS label, you can see an example in the bottom right here. It's going to have product identifiers, it's going to have supplier identifiers, it's going to have hazard pictograms, it'll have signal words like danger or warning. It's going to have hazard statements, precautionary statements. That's really the meat and potatoes. It'll kind of tell you everything you need. First aid, it'll tell you what kind of PPE you need. It's kind of an all-encompassing system. And then you're going to have supplemental information. That's going to be like the fill weight, gross weight, expiration date, directions for use. This is all very good information that is required to be on something for you to have in the workplace. You heard me talk about pictograms on the last slide, but we're going to actually go over the pictograms. There is different ones for different kind of dangers or hazards. So there's explosive. We'll start on the top left. That is explosive. Then we go to flammable. That's a line with a flame over it. Oxidizer. That's a line with a circle in the flame. We have compressed gas, harmful or irritant, dangerous for the environment, a health hazard, corrosive, and toxic. Skull and crossbones, pretty self-explanatory. It's either dead or severely toxic. Now you can see on this slide, this is just a quick card from OSHA. This is a perfect way to remind workers how to prevent accidents and avoid dangerous situations. These are free pocket-sized cards. They use simple visuals and language to reinforce common but crucial safety rules. Each quick card focuses on one topic for fast facts and clear instruction. This one is specifically going to be for Hazcom. This is actually going to be for labeling, most likely. Now we see an example of a alternate label. This is the NFPA 704 label. It's the most popular alternative label. It uses a numerical system to communicate hazards and does not have to have the key. So most of the time we see the diamond in the middle. This can be a little more confusing for people. It can be harder for people to use because you don't have the key, as you can see around there. I really don't think anybody, unless they do safety for a living, can tell you what a 4 for fire hazard on one of these labels are. That's why it can become difficult for regular employees to actually use these kind of labels. Here's another part of that quick card. As you can see, it kind of will help you with the NFPA 704 label. Again, these are very good cards. They kind of help you look at different information, give you just real quick examples of things, and helps you understand what they are. This is just the top section of the NFPA 704 information. Again, it's going to give you that information so you can understand the 704 label. Then we come to the HMIS Hazardous Material Identification System label. It gives a numerical system of the hazards, provides what PPE is required for the chemical. Again, usually you only have that left rectangle there. You don't have any other information. These can become difficult for people who aren't very familiar as well. That's why most people prefer the GHS label, because it gives you the information up front. These alternative labels are primarily designed to help emergency responders effectively manage emergency situations, not meant to replace the actual GHS label. Containers that chemicals are transferred into that will be used immediately do not actually need to be labeled either. So let's say you take some oil or something, you put it into a Gatorade bottle, and you're going to use that immediately. It's not going to leave your site. You're not going to walk away. That actually doesn't need a label as a secondary container. But if it's going to be a secondary container that you are going to have for a long period of time, maybe you're going to take your lunch break or something like that, it does have to have a label so people don't accidentally walk up, drink it, use it for something it's not intended for, and they actually know the dangers or the hazards associated with whatever chemicals in there. We're going to talk a little bit about the UN ID number. The UN ID numbers are placed on transport trucks or rail cars to help emergency responders identify the substance being transported. Emergency responders can look up the substance in the ERG or the Emergency Response Guidebook, which we will talk about in the next slide. So this is the ERG Guidebook. It's broken into 4 color-coded sections. Yellow, emergency responders can look up the chemical by the UN ID number. Blue, emergency responders can look up the chemical by name alphabetically. Orange, yellow and blue sections will take you to a guide in the orange section that will give guidelines on how to respond. And green, if a chemical is especially dangerous, it'll be highlighted in green, giving isolation distances and other important information. These books are very helpful, but it can be hard for newer people to learn how to use them. There is instructions in the very first pages, which will be very effective for you to learn how to use the actual guidebook. Now there is a mobile app that you can download. This is very effective because it gives you all these chemicals informations right up front. Just make sure that you are looking at the right chemical, make sure that you understand how to use it, and if you need any help, make sure that you ask for it. It is your right to know and your right to understand.
Evident 1222 information.
1222, go ahead.
Evident 1222 checking location. This 1050 is at Hicks and Gray Road, is that correct?
1222 FEM 104, that is what the caller advised.
2210. F&M 1222.
1222, go ahead.
F&M 1222, I'll be 1023, this 1050. Looks like we possibly have fire, I guess the smoke. Appears we got one victim down on the road, possibly one in the car. I'll be needing some assistance. What's the ETA on fire and ambulance?
1222 Effingham, 104. Kinmundy Alma Fire Department advises ETA 5 minutes, ambulance 5 to 7 minutes.
2210-4, advise ambulance and EMS to expedite. I'll be out of the car checking victims.
1222 1261 Effingham, 1020.
Hey, 1261. I'm at Route 51, just north of Vernon.
Buddy, hey, buddy.
1025 with 1222 at Hicks and Gray Road to assist with 1055.
All fire out.
Information. Twelve 1222 and status. District Subunit 2 non-answering status check on.
Hasten in the car and still conscious and breathing. Okay, let's get this guy out of here. Ready? Right over. One, two, three.
That was a great video. Now let's talk about the safety data sheets, or SDSs as they are commonly referred to. Safety data sheets are an integral part of the chemical inventory. They give specific information about the chemical, and they are the best resource or source of information about the chemical. They are formerly known as MSDS. A lot of people confuse them and go, I don't know what an SDS is, but I know what an MSDS is. They are technically the same thing. This is just reworked and retooled a little to follow the GHS procedures. SDSs are broken down into 16 separate sections. The length of the SDS depends on the chemical hazards. SDSs must be kept in a location where employees can access them in an area the chemical is going to be used. So we cannot take these SDSs, lock them in an office, and not allow people to use them. We have to have them readily available at all times. They also have to be in the predominant language for everybody in the workplace. Let's say you have someone who speaks Spanish, maybe French, something of that nature. You have to have an SDS that they can read as well. SDSs are required for all chemicals on the job site. Now you need training for hazard communication. So employees must be trained on the specific chemicals that are in their workplace. Training needs to take place before the employee works with the chemical, not after. All PPE will be available to workers. We have to provide it. And training on proper PPE will take place before the employee uses the chemical. Again, we cannot let them use the chemical, get hurt, and then go, okay, we will train you now. No, it needs to be done well before you start working with that specific chemical. There can be additional trainings as well, like having benzene training or NORM or TeNorm, which is technologically enhanced natural occurring radioactive material training. Some H2S training, usually H2S clear, and SO2 training, that is sulfur dioxide. That is what we get when we burn H2S, so it is prevalent in the workforce. This is the conclusion of this section. So hazardous chemicals can be at your work site. Make sure you read the SDS to protect yourself. Make sure you are properly trained to work with the specific chemical, and never respond to any emergency if you are not trained. Always make sure that you are trained before you respond. Now we're going to get into something a little more heavy. That is NORM and TeNorm awareness training. Now let's review the session objectives for NORM and TeNorm. So objective 1, learn what NORM and TeNorm are. Objective 2, learn history of NORM safety. Objective 3, understand types of radiation and background radiation. Objective 4, know how to use the SDS. And objective 5, understand that you have the right to know what hazardous chemicals are in the workplace, and again, how to protect yourself from those chemicals. So the most commonly asked question, what is NORM? What is TeNorm? Well, we'll give you the definitions. So NORM, that is naturally occurring radioactive material. It is materials typically found in certain types of barium or strontium, that is a hard word, scales that may be deposited in the wellbore or production tubulars. And then we have TeNorm, that is technologically enhanced natural occurring radioactive material. A little bit of a mouthful. The naturally occurring radioactive material enhanced by technological means. This typically is present in fluids and minerals such as sand and propent materials. We're going to go over what is NORM and TeNorm. So NORM consists of radioactive elements that are present in the Earth's crust and or geological formations. In some formations, NORM may accumulate in the oil and gas process equipment based on the production formations and the properties of the liquid and gases that are extracted. Supervisors and RSOs are required to perform radioactive or radiological surveys and analyze to determine exposure level. We'll talk about some history of radioactive effects. This was first understood in 1925. There was some suspicious developments around watch-dial painters. They had jaw lesions when working with radium. Dentists diagnosed lesions as jaw necrosis due to radium deposits in the jawbone. Doctors noted bone changes and anemia in dial painters. Radiation migrated to the bones, causing leukemia and etc. Employees working for decades for radium dial to accept the hazard, causing hundreds of deaths and serious illnesses. Let's go over the different types of radiation. So there is non-ionizing radiation. So that is radiation that does not have sufficient energy to dislodge orbital electrons. Some examples of non-ionizing radiation would be microwaves, ultraviolet light lasers, radio waves, infrared lights, and radar. Then we have ionizing radiation, radiation that has sufficient energy to dislodge orbital electrons. Some examples of ionizing radiation would be alpha particles, beta particles, neutrons, gamma rays, and X-rays. Then we have background or cosmic radiation. Background radiation is the radiation naturally emitted from the Earth and the Sun. At sea level, you have 30 MREM a year from cosmic radiation. At an altitude of 10,000 feet, you have 140 MREM a year from cosmic radiation. In this slide, you can see the concentrations of NORM in the oil and gas industry. As you can tell, here in North Dakota, we mostly have oil production radiation, or NORM. We don't really have a lot of gas or hybrid. It's mostly oil. Half-life. Parent radionuclides have decay times or half-lives comparable with or longer than age of the Earth, so they have always been present in Earth's crust and within the tissue of all living species. So let's talk about what radiation is. So radiation is energy traveling through space. Sunlight, radio waves, and microwaves are forms of radiation at low frequency ends of the energy spectrum. Type of radiation created by uranium is ionizing radiation, and then we have background radiation. Everyone exposed to naturally occurring ionized radiation from space, radioactive atoms in the air, the Earth, and even our own bodies. Most atoms are stable and will never change, but certain atoms are always changing or decaying in a process by which they eventually become stable as completely different elements. Some examples is like uranium will naturally turn into lead after billions of years. As an unstable atom decays, its atomic structure changes, releasing radiation as gamma rays and alpha and beta particles. Now we'll get into radioactive materials in the oil and gas industry. So naturally occurring radioactive materials, or NORM. Removed and concentrated incidental to gas production, so production brine. Scale buildup on equipment, pipes, tanks, etc. Potential exposure to workers and the public because of these things. And flowback materials during completion processes. So at the atomic level, most atoms are stable and will never change, but certain atoms are always changing or decaying in a process by which they eventually become stable. It's completely different elements. Again, just like uranium, it will eventually become lead over millions or billions of years. As an unstable atom decays, its atomic structure changes, releasing radiation as gamma rays and alpha and beta particles. We're just reminding you of these facts because these are very important to radiation. Now we're going to tell you what types of ionizing radiation there is. So we have alpha, which you can see in here is A. Radiation consists of a fast-moving helium-4 or 4He nuclei and is stopped by a sheet of paper. Beta radiation consists of electrons and is halted by an aluminum plate. We have gamma, which is represented by Y. Consists of energetic photons, is eventually absorbed as it penetrates a dense material. We have neutrons, represented by N. Radiation consists of free neutrons, which are blocked using light elements like hydrogen, which slow or capture them. Now we'll get into the testing or screening for NORM or TeNorm. So we have some survey responsibilities. So NORM screening surveys will be conducted as follows. On all equipment and material that is suspected to be NORM contaminated, at the facility inlet, within 1 year of fluids from a new reservoir being added to the process stream at the wellhead and associated piping, and when a new stream is added from a third-party producer. Equipment and material with NORM contamination exceeding twice background levels will be flagged as potential NORM contaminated with nylon flagging tape, orange or yellow, and will be investigated further when the equipment is opened or the material is uncovered. Surveys can only be conducted by a trained and certified Radiation Safety Officer, or an RSO. Here we have some training requirements. So this training is an awareness level course only. If any personnel within your organization are to handle NORM or TeNorm, additional training will be required. This includes knowing the health effects, the primary routes of exposure, procedures for minimizing and controlling exposures and environmental release, how to measure NORM, what to do if there's a release of material, awareness of disposal and transportation requirements. Consistent exposure to NORM may cause disease such as cancer, tissue change, and or potentially a shortened lifespan. You have to know the proper PPE and protective measures. You have to know the handling, storing, and disposal, the survey equipment, emergency response, and the location and contamination levels of the area. NORM and TeNorm can be found in oil, water, separators, pipes, tubing, and other oil field equipment. When it is found, it is typically found in the deposits, sludges, scale, films that accumulate on the inside of production piping and equipment. As you can see in the picture right there, that would be NORM material. Here we give you some examples of where NORM and TeNorm can be found. So produced water equipment, piping, tanks, treaters, surface and downhole pumps, and associated filters. On oil equipment, wellheads, piping, pumps, separators, heaters and treaters, tank bottoms, sludge holding tanks as well. And on gas equipment, propane piping, pumps, filters, and any kind of storage vessel. This slide gives you some potential NORM and TeNorm locations. Take a look at the diagram here to get a good feel of where you could find NORM. Here's some way to protect employees from NORM and TeNorm. Exposure to NORM is possible when performing any of the following activities: cleaning out tanks, vessels, piping and pumps, changing filters, or removing contaminated soils. Loading or unloading contaminated fluid could also expose you to NORM. The most effective way to reduce exposure is TDS, time, distance, and shielding. You want to try to minimize time around contaminated materials, use shielding barriers, and increase distance from the source. Some ways we could do this is with the proper PPE. So gloves, full body suits, face shields, and respirators. However, again, we want to remind you, the most effective way is TDS, time, distance, and shielding. Minimize your time around the contaminated material, use shielding barriers, and increase your distance from the source. Make sure you follow these. This will help protect you from NORM. And this is how radiation will affect your cells. So radiosensitivity theory of Benzene and Tribido, very hard words to pronounce. Cells are radiosensitive if they have a high division rate, have a long dividing future, are of an unspecialized type. These are the underlying premises for ALARA. The typical response for radiation depends on the total dose, the dose rate, the radiation quality, and the stage of development at the time of your exposure. We can have a full body effect. So acute or non-stochastic, very hard word to say, occurs when the radiation dose is large enough to cause extensive biological damage to cells so that large number of cells die off. Evident hours to a few months after exposure, so very early. Delayed or stochastic, again, very hard word, exhibit themselves over years of acute exposure, so either over a genetic level, a somatic level, or teratogenic level. Again, very hard words for NORM and TeNorm. On this slide, you can see some shielding examples, either lining something with lead or a dense material like concrete, putting something there so then it can block the radiation spread, absorbing material, stuff like that. That is examples of shielding. Here is the annual radiation exposure limits for occupational exposed workers. Go ahead and take a look at this diagram. Here you can see the required signage. So we'll start with the one on the left. Caution, the inside of this equipment is NORM contaminated. Use approved work processes or procedures when working on the internal parts. On the one on the right, caution, naturally occurring radioactive materials, authorized personnel only. The required signage just has to fit certain criteria set by OSHA, so make sure it does. Protection of the public from oil field NORM. So generally speaking, NORM located inside pipe and equipment does not pose a risk to the public at large or even those who work in close proximity to the pipe and equipment. One of the most effective ways to protect the public from oil field NORM is the proper management and disposal of equipment containing NORM and other NORM waste. This includes transportation to and from the location you find NORM. With that being said, we'll talk about the transportation of NORM. Transportation of NORM materials and contaminated surfaces The transportation of NORM materials will be subject to the North Dakota Department of Health and Radiation Control Program and the Department of Transportation Regulations, or DOT. This includes having a North Dakota approved waste hauler certification. Companies are required to keep complete laboratory reports and waste records for the initial identification of NORM through to final disposal of the NORM material. There are specific requirements for NORM and TeNorm contaminated material based on the survey data collected. When tools and equipment have fixed, hard to remove surfaces, NORM material will be disposed of as NORM waste unless decontamination can reduce the levels below required levels prior to disposal. This can commonly be accomplished through steaming or scrubbing materials if the radiation is not too entrenched in the material or the surface. So finally we get through NORM and TeNorm. I know that was a wild ride, a lot of information, but we're going to quickly go over benzene awareness. Here's the objectives. Learn how to protect yourself from benzene, learn exposure limits of benzene, learn what PPE is required for benzene, understand the routes of exposure, and understand personal effects of benzene. So benzene is a colorless liquid with a sweet smelling odor. It is a common component in crude oil and refined petroleum products such as gasoline, also found in substances like volcanic emissions and cigarette smoke. It is chemically known as C6H6. It is a carcinogen, meaning it causes cancer, specifically leukemia. It can also cause bone marrow abnormalities. In the early 19th and 20th century, it was used in many aftershaves and lotions because of its sweet smell. People started developing jaw lesions or boils and other stuff on their chest. We found that it gave people leukemia, and we quickly stopped using it. We'll talk about the benzene awareness flammability limit. So benzene is very flammable as well, so proper storage and keeping away from ignition sources is important. You can see the LEL is 1.8, that's the lower explosive limit, the lowest limit at which it will explode. And then the UEL, which is 7.9%, that is the upper explosive limit, the highest limit at which it will ignite. So its flammable limit is between those two, 1.8, 7.9. If you're at 1, it will not ignite. If you're at 8, it will not ignite. Has to be within that range. So workers can be exposed to benzene through inhalation, breathing it in, which is the most common route, and skin absorption, absorbing it into the body after contact. Inhalation is going to be our greatest danger. It's something we can't stop doing. You stop eating, drinking, and smoking. You can stop touching something and you avoid being poked and prodded, but you can't stop breathing. So out of all the routes of exposure into your body, breathing is going to be the most common and the most dangerous. Benzene, though, is highly absorbable by your skin. We can absorb it very quickly. Some symptoms for exposure can be blood disorders, headaches, nausea, convulsions, loss of consciousness, or certain kinds of cancers like leukemia specifically. We'll go over some protection you can have from benzene. Workers must be protected from exposure to benzene anytime the concentration is above the permissible exposure limit, or PEL. The OSHA permissible exposure limit is 1 part per million. So out of an 8-hour workday, you could be exposed to 1 part per million during that 8-hour workday. The short-term exposure limit is 5 parts per million. So for 15 minutes a day, you can be exposed to 5 parts per million of benzene before it has serious negative health effects. API recommends that there's no safe exposure limit for benzene, though. You should have an emergency action plan for benzene. If workers can be exposed to benzene levels above the permissible exposure limit, then the company needs to create and implement a benzene exposure control plan that includes setting up controls, monitoring affected workers, and maintaining documentation of the exposed workers. Some controls we can use would be proper ventilation, limiting access to places that workers can be exposed to benzene, training workers that will be working around benzene, and workers must be trained before they can work with any hazardous substance. So communication. Hazcom standards will be implemented to communicate the hazards of benzene exposure to workers. You have to have signs, warning labels, GHS labels, and safety data sheets. Some PPE we can use would be a half-face respirator with organic cartridge. That's from 1 to 10 parts per million. From 10 to 100 parts per million, you should have a full face piece APR respirator with organic cartridges, and 100 parts per million or more, a full face piece supplied air respirator SCBA or hose line with an inline escape pack. For skin contact, wear chemical resistant gloves, sleeves, and aprons. Wear chemical goggles and face shields, and wash the affected area in an eye wash or emergency shower station for 15 to 20 minutes and seek medical attention immediately afterwards. When we test for benzene, it's typically done in two ways, through badges or charcoal tubes, or through passive collection beakers. Designed for industrial hygienists, it's according to NIOSH 1501, determines how much benzene personnel are exposed to during an average work shift. In conclusion, just always wear your PPE. Just know benzene can make you very sick. Know it can be found in petroleum products, and protect yourself at all times if benzene can be present. Thank you for sitting through this safety meeting. I hope you learned something. Be safe out there, and make sure you protect yourself at all times.